Greetings, traveler. I'm the Calculus Cleric, and today we're going over differential equations. So the specific problem is find all the values of a such that y equals x to the a is a solution of y double prime minus 12x to the negative 2y equals 0. So the trick to this is going to be a lot of substitution. We're going to need to replace the y's with something to the x to the a because we need our variable a in there because they want us to find all the values of a. So they give us that y is equal to x to the a, and we can use this to replace first y double prime. So we need to find the second derivative of y. So y prime is equal to a multiplied by x to the a negative 1, and then we take the derivative of that one more time to give us y double prime, which is a multiplied by a negative 1 multiplied by x to the a negative 2. So now we can replace y double prime over there with this over here. A multiplied by a negative 1 multiplied by x to the a negative 2 minus 12x to the negative 2y is equal to 0. Now here's the problem. There's another y in here. We only want a's and x's. So we can get rid of the y by replacing it with x to the a. So a multiplied by a negative 1, x to the a negative 2. Okay, now we can simplify things out, mainly on the second half of this equation. As you can see, both the bases are the same, x and x, so therefore we can just add the exponents together, which gives us x to the a negative 2 is equal to 0. Now this makes it really convenient for us because if you notice, there are two x's to the a negative 2's in both parts of the equation. Therefore, we can factor this out. And it leaves us with this. Now, this is really convenient because x to the a negative 2 can never equal 0, so we don't have to actually worry about this part at all because anything to any exponent really can never equal 0 unless it's 0 itself that has an exponent on it.
And since we can't manipulate x but only a, we can't get the base to equal 0.
So we need to figure out when this becomes 0. So when we separate it into its components, we can see that a negative 4 multiplied by a plus 3 is equal to a squared negative a negative 12 when we multiply them back together, and that these individual components will make it a lot easier to solve for 0. So this part becomes 0 when a is 4, and this part becomes 0 when a is negative 3. And so these are values for a that will make it so that y equals x to the a is a solution for y double prime minus 12x to the negative 2 multiplied by y equals 0.